So I have these two tomatoes. Let's ask around in the office, what will they choose? This one or this one? But the catch is, this is a genetically modified tomato. But these guys don't know that yet. So let's see, what will they pick? Hi Nishita. Hold this. Which one will you choose?
This one.
This one.
That one.
I'll go for this one.
Why?
Because it's bigger and brighter.
It looks better.
I think it's more red and big in size also.
What if I tell you this is a genetically modified tomato and this one is organic? Now what will you pick?
Oh, now I'll choose the other one.
The organic one.
Then I'll choose that one.
Kyun?
Because I heard they use injections and all to grow these crops. So what if I get sick?
Because I don't know what chemicals they have put into it and how it will impact my body.
This might cause me allergies.
I think I've heard that there's some liver disease that happens.
So these guys were not able to tell the difference, but can you?
So as you can see, people can't tell the difference between GMO and non-GMO, but everyone has an opinion on it. So in this episode, we'll talk about what is GMO. Hey Abid, what's up?
Hey.
So tell me, what the hell is GMO? Humans love tinkering with nature's design and feel like God. One of the oldest examples is artificial selection. Yes, this artificial selection has been a thing since way back when the cavemen first figured out you could get different doggo varieties by letting only the chillest wolves make puppies. Basically, we bred only the traits we wanted and bred out the traits we didn't. And once we graduated from the caveman life to this crazy little thing called agriculture, we just had to keep messing with nature's menu. All of us are so choosy, aren't we? By picking which plants and animals got to pass their genes to the next generation, we essentially hacked the system. And all those years of selective breeding and artificial selection gave us the modern day crops like corn and animals like the American Jersey cow, who, by the way, are wildly different from their ancestors. Thank you, genetic engineers. I'm sure nothing bad will come from radically shaping species just because we can. But hey, enough about ancient history. Today, we're basically living in a Gattaca-level future to directly gene-hacking organisms into genetically modified organisms, or GMO for short. Unlike what people think, GMOs are not made by artificial breeding or injecting chemicals into crops. They're actually made inside labs, where scientists alter the DNA of crops to produce the desired traits. Drought-resistant crops? Check. Herbicide-proof super plants? Why not? We're basically bioengineering dino-sized products over here. No biggie. It's just like that if it ever backfires, like in science fiction, it'll be fine. Right? Right. Right, guys? Well, let's explore this topic of artificial selection and GMOs a little more in detail. And then maybe you can decide if humans playing God is good for the future or not. God, but this has been happening for a while, right? Like, I mean, think about it. Artificial selection has been happening for some time now.
Yep.
All the race horses.
Yep.
Actually, even the greyhound, which is bred, which is artificially selected to run.
Yep.
All these kinds of animals are actually selected in such a way that they can actually run races and win. I'm sure the camels in Arabia are also selected like this.
Correct.
So they'll take a litter.
Yep.
They'll pick the dogs which ran the fastest.
Yep.
Breed them again.
Yep.
And keep going. And over
Yep.
10, 20, 30 generations,
Yep.
they'll find really fast dogs.
Absolutely.
And this is artificial selection. Same thing with cows.
High yielding varieties of cow, Holstein.
Huh.
In fact, interesting thing that you mentioned horses. So, you know what is the name which you give to race horses? There's a specific name. They are called thoroughbreds.
Oh, right.
They are bred
for that purpose.
For that purpose.
Same for Arabian horses, right?
Arabian horses are not really into the racehorse running scene, I guess. I'm not sure.
A lot of them are done for beauty as well, right?
Yes.
Which is another example of artificial selection.
Yeah. So cows, horses, dogs, as you mentioned, plenty of selective breeding happening for centuries.
So means if we go back in time, we will not see those special cows which yield so much of milk.
100%.
It'll be far, far less.
100%.
And then humans changed it for what we needed.
Yeah, 100%.
But it's done over a longer period of time.
Very long time.
What about like natural selection?
That's the thing, right? So there are some instances where naturally this can intermingle. right? For example, a lot of willow trees, a lot of orchids, grapefruit, which is found, I think, in the Caribbean or some area like that. That was not a naturally occurring plant. The first time it happened when there was a sweet orange which occurred there, which mixed with another fruit called pomelo, and then grapefruit came around. There are natural instances where crossbreeding has happened also. So yes, there is natural crossbreeding.
Then we also have like artificial crossbreeding, right? So we have like a tiger.
That is us doing, yeah.
That's us, right? And then we get the liger. We actually have like these images, these videos of ligers walking around,
Yeah.
but I think they don't exist anymore.
So in nature, it is very difficult to get a lion and tiger to, go behind the bushes.
And
And flowers come,
Just
like
do it.
how in 1990s movie, flowers come and like bees are pollinating. That's kind of imagery. They don't do it.
so point is,
But in a captivity, they do it.
they do it
Mules, horses.
because you made them do it.
You didn't make them. You gave like flower ka background and they...
So the point is, genetic changes in species has happened over centuries, over the long time.
Absolutely.
In our food,
Absolutely.
in animals,
Absolutely.
in flowers.
Yep.
It's been there for a while.
Yep. 100%.
This is not new.
This is not new.
Like we discussed, genetic tinkering is basically humanity's oldest pastime. But playing mad scientists by crossbreeding over many generations was kid stuff. It wasn't until 1973 that we unlocked the real treasure: decoding DNA's genetic code. Scientists at Stanford created the first genetically modified organism that year by implanting bacterial cells within a gene from a virus, a microbe infused with an
Alien DNA. I wonder what could go wrong.
But it was really this, the flavor saver tomato in 1994, that ushered the GMO food era. Tweaked to delay over-ripening, it was the first gene-hacked crop approved for human consumption. Today, GMOs are utterly inescapable. Over 90% of major crops in countries like in the USA have corn, soy, cotton. They're all genetically engineered, modified to be herbicide resistant, drought proof, fortified with extra nutrients and whatnot. However, in countries like India, we still have not adapted to GMO to a large extent. And the only widespread GMO in use here is something called BT cotton. And we'll talk about BT cotton later, but first let's look at the present situation. We're like horticultural gamers today, cultivating our dream crops down to the genetic code with glorified cut and paste tools like the CRISPR. It's like we're playing Farmville or something. And that's where the controversy comes.
Were held in dozens of cities around the world today against
GMOs,
GMOs,
GMOs.
genetically modified.
organisms. People care about what they're putting in their bodies, and they want to know what's in the products that they are eating so they can make that decision.
Deregulated the GMO industry.
We don't need no GMO! Say no to GMO! Hell no, GMO!
Who in many ways would prefer that people not know what is in the food that they produce.
With big seed companies playing mix and match with plant genomes, many argue we're opening a Pandora's box of unintended consequences. Potential threats could be toxic side effects, mutated superbugs, and an ecosystem disruption could have plenty of folks calling for GMO regulation and maybe an outright ban. But of course, the biotech bros are here to argue that genetic engineering is simply hyper-accelerating the age-old practice of artificial selection to help feed our own booming population. But hey, modern food science has to start somewhere, right? What do you think? Dude, but the thing about GMO is, there's extremes. There are people who love it, they say this is the future, yahi solution hai. And there are people on the other side who say, nahi, chemical hai, we cannot do this is harming the environment, it sucks. What do you think?
Okay, so I'll be very honest, right? Rather than taking an absolute stand against something, I'll kind of tend to look at who is behind it, right? So for example, Jonas Salk invented polio vaccine. Amazing man, right? Oral polio vaccine. He was the guy who was behind it. And he said, this vaccine does not belong to me, it belongs to humanity. And he donated the patent of the vaccine to some university or something, I think, and which is why billions of children get oral polio vaccine every year for free. I think this is one of the monumental moments of science where men of science and women of science proved that, boys, listen, we are here to save the planet. There's no greater shining example of science being altruistic than, right?
The polio vaccine.
But if a pharma company comes up with a vaccine, I'm like, So
commercial interest.
I can't trust the. I can't trust the reason why somebody is doing something if there is shareholder value maximization involved, and that's just me, right? But if a person of science does it, right? If ISRO launches a rocket, I'm like, probably they are doing it for the country. But if SpaceX launches, I really don't know what's going on in the agenda. Not that I have any definitive proof, but you get the meta. My single biggest source of skepticism against mass proliferation of GMO is that it is mostly done by I don't know what they are called, big seed, big GMO, big something,
big seed,
but big commercial interest, right?
Yeah.
And this is my problem. Let's say that there is a 0.00005% chance that a GMO can cause, let's say, a 3% impotency in you. Just
why impotency?
That's what everybody is bothered about, right?
Something else.
People are bothered about that more than that. Like, if I tell somebody that there is a 50% chance of a really gruesome death if you smoke cigarettes, versus in next 3 years you might have slight impotence, people are like, boss, I'm quitting today. In fact, I think the labels on
should say that.
In cigarette packet learnings, instead of saying, boss, kutte ki maut maroge, change it saying that, boss, you might become impotent. Tomorrow, half the people will. Just say, right? So if there is a trade-off like that, then the World Organization will say that, boss, everybody around the world, smart people will agree that these are negligible statistical odds. Therefore, it's probably better to do GMO because it feeds much more people. Greater common good is better. Although there's a sliver of people who might be adversely impacted. So maybe GMO has a problem. Maybe GMO does not have a problem.
No,
but everybody is incentivized not to make people panic.
Correct. Most people make decisions not on the basis of data. Like even this show, we say we'll show data. In the end, every decision is an emotional decision.
Correct.
If people think, mere fruit mein injection dala hai, and there is some chemical inserted, and they feel that's what GMO is, or whatever, people will not gravitate towards it at all because every decision is an emotional decision.
Correct. There's another thing, right? Even if you're not having GMO, even if you're having a normal fruit, there's so much pesticide, insecticide in it, which probably has a 100x probability of giving you cancer than some inconclusive evidence about some GMO giving you something exists.
Yeah.
So people get worried about the wrong things. They hooked on to, there is a 0.001% GMO. So maybe that's why the scientific community is gravitating towards. So if you ask me, do I trust GMO? I don't know, because I know the world make decisions based on what people can handle. The mainstream narrative of every single thing in the world depends on what people can handle.
If you've liked the episode so far, hit that like and subscribe, and don't forget to comment. So my question is, would people move towards GMO if it made logical sense? Or is there something else over here? Does it just not feel right because you don't trust it?
So like I said, right, part of the reason is that people have a tendency to resist anything unnatural till it becomes normal.
Correct.
Right? That's a very legit concern. I mean, even I have a concern. And let's acknowledge it, right? If you objectively look at GMOs, they are probably 20-25 years old when it comes to food we eat. Maybe I'm pretty sure it's not more than 50 years old.
Which is recent.
It's not long enough data to conclude anything. And also you have to look at it in the lens that there's a lot of money being pumped in to make sure that a wrong information. So a lot of capitalism controls a lot of big pharma and big seed and also a lot of media. Even if there is something very controversial about GMO, if the media houses around the world are controlled by the same dudes who control big pharma, what are the odds that they let that news float?
And to add to that, you mentioned media, pharma, and big seed. I don't know what they're called. These are not even 5 companies each which control everything.
Yeah.
That's scary.
That is scary. But
because if they control the narrative, like we talked about EVs, you can just change the story. One problem here is we don't really know how it will react in the natural environment. The concern is, like we were talking, is that one crop breeds with another crop in the natural environment and something else happens which we cannot predict.
Correct.
And because all of life is connected to each other, the water table, the roots, some other tree, the food, what would happen to the entire system?
Yeah.
What if we literally introduce a virus?
Correct.
And something happens to our food system?
Correct.
That's one huge concern.
Correct.
I have no idea. How would we even test for that?
I don't think you can really test long-term impact of what happens when you introduce a new organism in the nature. But see, the thing is this, right? If it's very specifically controlled gene modifications. So at some point, we also have to be rational enough. Suddenly, let's say that There's a way in which we can make blonde-haired children or blue-eyed boys, literally. Right? What if he grows like 10 hands tomorrow? That is paranoia.
Yeah.
So at some point we have to understand that, okay, if it's very lab controlled, if it is very precise and you exactly know that this gene controls only this thing,
And
paranoia.
I think add to that, right, the effect of time. If you do this over another 5 decades, I'm sure we'll figure it out, but we're definitely not there yet.
Yeah. But the problem, of course, is in the process where this thing becomes dominant species, what is the cost that other species will pay is less debated. So, for example, earlier we were saying, right, there's a herbicide problem where instead of making plants which are resistant to insects, you're probably making plants which are resistant to insecticides because, you can sell insecticide more. But the problem is, now you'll spray a lot more insecticide. One problematic thing rather is, we don't know if we spray indiscriminate amounts of something which is poisonous to one species, what else it will affect.
But even the local farm is affected, right? Like we said that a certain kind of crop is resistant to herbicide.
Yeah.
So the farmer will come and he'll start spraying lots of herbicide without worrying about it. And to take care of weeds, but not all weeds are bad.
Correct.
If all weeds are taken care of, gone from there, the farm looks different, looks cleaner, but now you have soil erosion issues.
Correct.
There are a whole host of other issues which have propped up to try to solve a singular problem without thinking the network effect it has on the entire farm.
But again, we have to be cognizant, very mindful of the fact that GMO did not cause the problem. The GMO which was created to sell more chemical is the problem.
Maybe Abid is right. Maybe the problem lies in how GMOs are used and not the GMOs themselves. But before we take that decision, let's quickly go through some of the problems that could exist directly due to GMOs. Now, while genetic engineering has given us modern marvels like drought-resistant crop and vitamin-boosted bananas, plenty of people have serious objections. So, let's understand this through 3 different perspectives. 1. On the health front, critics warn that tinkering with nature's source code could produce unexpected toxins and trigger new food allergies. A 2020 analysis found about 51% of people believe GMOs likely pose health risks. And think about it, the long-term impact of ingesting GMOs is still largely untested over multiple generations, right? So we could potentially be guinea pigs in an uncontrolled experiment. Number 2, then there are ecological concerns. Genetically modified supercrops that are designed to survive high concentration of herbicides, well, they could breed herbicide-resistant superweeds. Now, while on one hand, GM crops help decrease the use of pesticide, on the other hand, it's increased herbicide use by a whopping 239 million kilograms. Number 3, the ethical debate is also a philosophical nightmare. Even if GMOs end up becoming technically safe, critics question the morality of corporations patenting seeds that produce 80% of our food globally. But of course, advocates counter that genetic engineering is simply an extension of artificial selection that humans have practiced over 10,000 years of agriculture. Either way, one thing is clear: the rise of genetically modified organisms on our dinner plates has opened up a door we may never be able to close. One of these manufacturers says that we've created this kind of crop, take our seeds, it will be resistant to insects. But sometimes that's not what's happening, is it?
I don't know what's happening.
Sometimes the insect actually gets resistant to that type of crop and still attacks it. And despite using the GM crop...
You mean resistant to the kind of chemical that's being
kind of toxin it's emitting to get resistant to that kind of... he gets resistant. And
so it's just like antibiotic resistant bacteria.
Same thing.
Basically, you
weeded everyone out, every insect out, which
so the only
actually
ones
died.
who are left are resistant, and then they multiply.
And then they reproduce, and that becomes the new strain.
So basically, indirectly, you're genetically, selectively breeding
the
insects which are resistant to toxins. So,
but what's interesting, right? As a capitalist, this is a great opportunity. Now you have BT2, BT3.
But you do realize that it is a opportunity that eventually leads to we are all dying.
Exactly.
The same thing happens with cotton, right? Like you look at it as an independent individual farmer. Like when a pest or a weed comes and attacks his cotton crops,
Yeah.
the easiest thing for that thing to say is, yeah, this year I'm going to get so badly affected because my crop is like going to die because of this insect. There are two thought processes for him. One, spray the insecticide,
it.
right? The other is, nay, if I do this as a community as a whole, this will create pesticide, insecticide resistance insect. Nobody is going to think
No
like
one thinks like that.
So again, it's about creating very tempting incentives, right? So this cannot be solved at a farmer level. Just like how antibiotic resistance, if somebody is falling sick, you cannot lecture him ki, bro, if you don't have this antibiotic now, tomorrow there will be a better world. Nobody's going to listen to that.
This happened with this BT cotton, right? So the BT cotton is supposed to save the farmer from bollworms. And now the farmers are reporting that the bollworms are resistant to that kind of toxin in the GM crop.
Correct.
And the bollworms are back.
Correct.
So now what?
Now you have to find something which kills the new variety of bollworms.
So part 2, new addition seed.
Yeah, it won't end. It's just like antibiotics.
It will never end.
So this is going to be a massive, serious ecological concern, because the amount of organisms which are evolved to fight chemicals will proliferate so much that your chemicals have to be much, much more deadly going ahead. And if it's not a different chemical, but it's a stronger, deadlier chemical, this is not going to end well.
Hey, tell me this. I genuinely don't know.
Okay.
In financial markets, we have the consumer and we have the manufacturer.
Yeah.
And in between, we have SEBI. To make sure that because the incentives are actually never aligned for these two parties, to sort of add rules and regulations to align them. Correct? Now, in this entire thing that we're talking about pharma, we're talking about these guys. Shouldn't environmentalists play a huge role in all of this? Like, where is their say? Where are the researchers saying? Because the researchers are hired by the manufacturer in this case.
Correct.
Where is the autonomous body of researchers saying, no, aisa nahi, aisa hoga, between the farmer and the manufacturer? Does this exist anywhere?
I think there's a regulatory body all over the world, in every country, which approves the use of a new chemical on anything. Like
FDA equivalent.
FDA equivalent is there in every country.
But do they really enforce it? I don't think so, right?
No, I think they are being enforced because, for example, right, I think in India, a lot of GMOs are not proliferated because they don't have the permission. I think BT cotton has permission, which is why
Correct.
it's...
And there's no other GMO allowed.
I don't think there are other GMOs being widely approved now. So there is regulation. But the problem is this, right? It's really, really difficult for a regulator to take a stance on its own against something where there is so much money riding.
I mean, that's why it's a difficult job.
Even rating agencies, right? I mean, it's like Big Shot openly says
Dude,
it. FIFA.
Like, I mean,
it's everywhere. Too much money can kind of buy anything. I mean, let's face it. There's no way escaping that.
Okay, wait. Let's pause for a moment and take a deep breath. Although there are certain key issues, on the flip side, genetic engineering could just be the key to solving some of humanity's biggest food problems. Like feeding our ever-ballooning population as our planet heats up thanks to climate change. Experts estimate we'll need to roughly double our food production by 2050 to feed about 10 billion people. But rising temperatures, droughts, and soil degradation put a serious damper on crop yields. This is where GMOs come to the rescue. Biotech wizards have already turbocharged staple crops to be drought-tolerant, pest-resistant, and equipped with productivity-boosting traits like fungal defenses. We're talking about everything from flood-proof rice that can survive underwater for over 2 weeks to bio-fortified bananas packed with enough vitamin A to prevent up to 700,000 kids from going blind each year. Speaking of nutrition, switching out genes has already given us all sorts of fortified superfoods. There's golden rice enriched with vitamin A and soya beans expressing genes for healthy omega-3 fatty acids. I mean, heck, there's even hypoallergic peanuts for those 32 million Americans with life-threatening nut allergies. But it's not just food where GMOs could make a massive impact. There's also our growing energy needs. We're rapidly bioengineering biofuel feedstock like algae and biodiesel crops as a replacement to fossil fuels. Then we have medical needs, like say insulin production, with just one single GMO insulin source meeting over 40% of global diabetes demand. And guess what? Gene editing may even let us basically grow plant-based polymers as a natural biodegradable replacement for plastic. Alright. Obviously, lots of this future biotech sounds uncomfortably like a sci-fi movie. But if it lets us sustainably feed billions, curb diseases, kick fossil fuel addiction, and save the planet, that's something pretty tough to argue with, right? Well, before jumping to any conclusions, let's see what these two guys have to talk about the pros of GMOs.
So GMOs are way more high yielding, right? Even naturally selected ones, which were crossbred, were high yielding. I mean, we don't have too many better examples of this than right here at home.
Yeah.
Green Revolution was selective breeding of high yielding varieties of rice and wheat, right? And now look at the GMO twist of it. So genetic engineering was brought in to achieve this selective breeding, which took over a process. I mean, normal selective breeding takes months, if not years. So you can achieve much better results, much faster, resulting in much higher yielding crops.
So you can scale faster.
Scale way faster.
And feed all of us.
Feed every person, bringing down the cost drastically.
And this problem is increasing worldwide, right? Like we'll get to 10 billion people by 2050. We definitely not at the current pace, we'll run out of food.
So there's no denying that a lot of mouths are getting fed because of things like green revolution. Although there are concomitant negative effects like use of pesticide, but
correct.
At the end of the day, you can't be like a complete, anti-technology natural person who says ki boss nahi ye sab nahi chalega, because people will die of hunger.
Yeah.
If you're taking that stance. So this is undeniable.
Secondly, you could actually add a nutrient to a particular kind of food.
Very simple.
And now you have it. So like we have vitamin A in rice, we have omega in soya bean.
Yeah.
What else?
There is biocertified sorghum. There is high vitamin E tomatoes. There is oleic acid in soybeans. I mean, there are plenty. So,
and this actually reduces populations which have a deficiency.
Yeah.
And actually saves better quality of life, etc.
Yeah. The most famous example, of course, being the one you quoted, which is called golden rice in East Asia. But the catch is this, right? It won't end here. There are so many things. The possibilities in future are endless. You realize that a particular deficiency causes a particular thing. Let's say a high dose of vitamin D reduces the risk of X kind of cancer. Or let's say there are vegetarians in the world who can't have access to vitamin B12 because it doesn't. So if you can somehow create genetic engineering which results in vitamin B producing proteins in some plant, then for a lot of people who are vegetarians by choice, because of their sentimental reason, they will get the benefit thanks to this genetic engineering. Right? So this change is very welcome, and you can practically engineer foods which exactly go and hit the exact protein that you need to be resistant to this disease or having this trait or being healthy in this way, etc., etc. So that's also like a world of possibilities that awaits us. So another very visible out there possibility that we can all see when it comes to GMOs is they are resistant to diseases. So from a farmer's perspective, they don't get attacks like, so I think there was a Hawaiian papaya which used to get a virus. So in Hawaii, papaya is a very widely grown plant, and I think some kind of virus was affecting every papaya. They brought in GMO to the action, and the new papaya strain did not have virus. So farmers ke liye it's great, because you have
their chance to zero reduces.
Yeah, they can get bankrupt of the entire. So they have crops which don't get affected by viruses. They also have plants that don't need. So if there's a plant which is getting attacked by an insect, if the plant itself is resistant to the insect, they don't have to spend on insecticide.
So I think in the US,
very common.
90% or I think some really large number like that is all GM crop.
Yeah.
And if you look at this chart, all of the yields have gone up throughout. And you can see that all of the yields have actually gone up and the usage of pesticide has gone down drastically. So, ये तो fact है, this has happened.
Yeah, this has happened. So that's one more benefit that you have. And of course, you have to give it to the environment also, because if you are having plants which are insect resistant, weed resistant, etc., then you don't spray so much herbicide or insecticide or weedicide. So the use of chemical decreases.
Yeah.
In a perfectly
ideal
aligned
world.
In an ideal world where crops are engineered to be resistant to insects and not the chemical.
They're also engineered to look a certain way, right? Like have you seen the spotless banana, like the spotless guava? Like it just looks...
seedless watermelons.
Seedless watermelon.
So that is also a good thing, right? There is a very positive effect on nature because the use of chemicals is being cut down because of GMOs.
So now there are a bunch of misconceptions that people still have. So Abid will say a misconception. We'll try to answer it based on whatever humanity has so far. Let's see if we can do this. Go.
I'm going to put on my imaginary reading glasses for this. The biggest concern with GM crops is that they may breed with non-GM crops, due to which their genes will get transferred to normal crops, which may affect the entire ecosystem of plants negatively, and it is also creating trust issues among customers.
Interesting. Here's the truth. So far, this has never happened. There is no instance of this happening. Having said that, it doesn't mean that it could not happen in the future. But so far, no instance recorded.
Misconception number 2. They may cause allergic reactions because of their altered DNA, and we don't know the long-term effects of growing and consuming these crops.
That's actually a really fair point. What we know so far is, over the last 20 years, America has been, 80-90% GM crop. We've not seen any noticeable reactions to the population over that. But having said that, 20 years is still not a large enough time scale to know all the effects. Agriculture is 10,000 years old. 20 years is piddly in compared to that. We probably need a few more decades. But so far, no evidence for this. And what's interesting is, a bunch of studies have said that none of this happens. It's actually safe. Now, I don't know who's funding these studies, but this is the information we have so far.
I see. Misconception number 3. In GM crops, genes are altered so that the crop creates a poison to kill insects. So if we eat that same crop, that poison will be bad for us as well.
Oh, interesting. So here's the truth. This is pretty straightforward. Engineering means you engineer it for a specific type of behavior. Poison is relative. Poison for an insect may not be poison for humans. So it's engineered like that. Of course, it is not poisonous for humans. We all have consumed some kind of GM crop at some point, and of course it's not. So this is unfounded. For example, chocolates are great for humans. I know you like it. No, you don't. But it's really bad for dogs. It's almost instant death if you give chocolate to a dog. So poison is relevant.
Fair point. Point number 4. Some insects have developed resistance to the toxins in GM insect-resistant crops. To kill them, farmers need to use much stronger chemicals which are expensive and cause pollutions.
Totally fair. If you think about it, insecticide they would use anyway, but with a GM crop, actually you know that on a population level, on a large sample size level, overall insecticide use has fallen, as you can see over here. Crop yields have increased, and we've seen this in the US. This is true. Second point you said, second thing to address over here is the use of insecticide. When there is resistance developed, will they use more insecticide? Yes. So this is a spiral where another GM crop will be introduced, and I think that's just how the system has become. So is GMO good or bad? What do you think?
I have no idea.
We don't know.
We don't know.
What's your perspective? Put it in the comments, and
Prateek will read it. Pakka.
Bye-bye.